Hello, welcome. Let's try to solve another Leetcode problem. 3296, minimum number of seconds to make mounting height 0. So for this example, for this problem, we are giving a mounting height, and for each of the time, we can reduce the mounting height by 1, and we are also giving this worker times array. Yeah. So this means for each of the time, if for this worker, the first worker, were to reduce the mounting by 1, so for example, here is 4. If it to reduce by 1, it's going to take 2 times. If we still going to use this worker, if we still want to reduce by 1, so next time it's going to reduce, so the time gonna become 4. Yeah, so the total time going to be 2 plus 4, going to be 6, and similarly for others. Yes, but all those workers can work at the same time, so this makes the problem a little bit harder. Yeah, so let's just try to understand it. So one way the height of the mounting can be reduced to 0 is, so for the worker 0, it's gonna reduce by 1, so it's gonna take 2 seconds, it's here. And worker 1 gonna reduce by the height by 2, so it's gonna use 2 times. So for the first time, it's gonna take a worker times 1, and then worker times 1 times 2, so it's gonna be 3. Basically, it is 1 plus 2, it's gonna be 3. Yeah. So now for worker 2, it's gonna reduce the height by 1, and it's gonna use 1 time. Finally, we're gonna choose the maximum of the 3, so it's gonna be 3 seconds. Yeah. So for this one, definitely we don't want to use the first worker 2 times to reduce the mounting height, because 2 times it's gonna become 6, and 6 is gonna be bigger. Definitely we just want to use 1 time, because if we use 1 time, actually we consume 2 seconds. It is okay. Yeah, but for the second worker, it's gonna consume 3 seconds, so it's gonna reduce the height by 2. Yeah, so the first one gonna reduce by 1, the last one gonna reduce by 1. So in total, it's gonna reduce 4, and the maximum time gonna be on 3. So what kind of data structure we're gonna use to solve such kind of problem? Yeah, so for each of the time, definitely we want to choose a smaller value. I mean the total times. So our idea is for all the workers, we're gonna record a total time for each one of the workers, and for each of the time, we're gonna put this total time inside the priority queue, and for each of the time, we want to pop it out and to check this total time, and finally, we're gonna choose the maximum of this total time. Yeah. So maybe it's confusing, so let's just try to code it up, and I'm gonna explain why. So I'm gonna prepare a result 0, so this is gonna be the final result. Now I'm gonna prepare a worker times array. So currently for this array, I'm gonna update it with a tuple. So inside, I'm gonna give a unit. So the unit means for each of the worker, it will use a unit of 2, 1, 1. So this is gonna be the unit. So from the beginning, I'm gonna give a unit for the first place. So this means the accumulated time for each of the worker, because finally I'm gonna choose the maximum of the accumulated time. Yeah. So for the second place, I'm gonna give a unit, and the third place, I'm gonna give a counter. So the counter gonna be 1. So for unit inside the worker times, and then I'm gonna heapify. I'm gonna heapify the worker times. So if we are doing it in this way, definitely the first index gonna accumulate all the time. So the second index is gonna be fixed, and the third index, it is just a counter. So we're gonna count it 1 by 1, because we need to meet such kind of a formula. Basically, worker times I plus worker times I times 2, and plus worker times I plus 3. It's gonna be something like that. This is why we're gonna design such kind of a tuple. Yeah. It's gonna be 3 variables, and we're gonna put it inside a heap. Now we're gonna check the mounting height. While the mounting height is more than 0, so what we're gonna do? Yeah, we just want to pop out the time, the unit, and the count. It's gonna be the heap pop with the worker times. Yeah. Now we can reduce the mounting height by 1, because definitely we're gonna use it. But before that, let's just try to record the final result. It's gonna be the maximum of the result and with this time. Now we're gonna reduce the mounting height. It's gonna be reduced by 1, so for each of the time. Now what are we gonna do? Definitely we want to put some value inside the priority queue. Yeah. So the condition is yeah, I've already forgot it. I just solved it this morning and then forgot about it. I think there must be something else I need to do. Yeah. So for each of the time, if the mounting height is more than 0, definitely I want to pop the time, the unit, and the count, and I'm gonna record the final result. I'm gonna reduce the mountings, and finally I want to push it inside. So I'm gonna use the heap push, and it's gonna be with this worker times, and it's gonna be a tuple. So first of all, it's gonna be the time plus the unit times the count. So for each of the time, yeah, and then I'm gonna fix this unit, and the count gonna plus 1. So finally, I'm gonna return the result. Yeah, so the idea is that, so for each of the time, I'm gonna pop the worker times, but I'm gonna pop out the smallest time. So for the first index, it's gonna be the smallest one. So for example, I'm gonna pop this worker first. So if I pop out this worker, so currently I'm gonna have a value of 1. So the time is 1, and the unit is 1, and the count is 1. I'm gonna pop out this tuple, and I'm gonna record the result. It's gonna be this result, and then the mounting height is gonna minus 1. So before it is 4, now the mounting height is gonna become 3. And if I pop out this value, definitely I want to put some value inside. And what I need to put inside, it's gonna be another tuple. So it's gonna be 1 plus the unit gonna be 1 times the count. Yeah, so here the count, it is not here the count should be 1, but here this count should also be 1 as well. This means something wrong with my code. Basically I need to update the code first, and then I'm gonna use this count. So I'm gonna use the unit times the count. Yeah, let me try to run the examples again. So here for the first one, definitely it's going to be a tuple of 1, 1, 1. It means my time is 1, the unit is 1, and the count is 1. And then I'm going to put something inside. So what I'm going to put inside, it is 1 plus the unit. So the unit is going to be 1, but the count is going to become 2. So I'm going to put a 3 inside, and the unit is going to be 1, and the count going to become 2. I'm going to put this tuple inside. Yeah. So what other tuples do I have? I still have this kind of 1, 1, 1, and I also have something like this 2, 2, 1. Yeah. So this is everything inside of the priority queue, and this is for the first time. And what's gonna happen for the second time? So for the second time, definitely I want to manipulate with this one. So this one gonna be popped out, and something I'm gonna put it inside. It's gonna be 3, 1, and 2. So this is currently what I have. Yeah. So this is for 2 operations. So currently the mounting array becomes 2, and this is inside of the priority queue. So next, I'm gonna just pop this out, and I'm gonna update it. So this one gonna become 6. The unit gonna be 2, and the count gonna become 2. Yeah. And currently this mounting height gonna become 1. And next I'm gonna pop out this one. If I pop out this one, so what's gonna be the maximum value? It's gonna be 3. and the mounting gonna become 0. Yeah, so I don't need to take care of this code and the heap boost because the mounting becomes 0 and my final result gonna be 3. Yeah, so this is exactly what we are doing. Now let me just run it and submit it to check if it works. Yeah, as you can see, it works and it's pretty fast, and the time complexity is how many, what is the height of the mountings? It's going to be 10 to the power 5. Let's just set it as n. And what is the heap? It is 10 to the power 4. So basically, it is n log k or k log n time for the time complexity. That's why it works. So definitely, I think this is going to be a good question. So definitely, we need to design something for this problem, and normally we're gonna design 3 variables. So basically, we're gonna use those 3 variables and put it inside a min heap. And for each of the time, we're gonna pop out the minimum value. Yeah, so for each of the time, we're gonna pop out the minimum value, and the final result is gonna be the maximum of the minimum value. I think that's all about it. Thank you for watching. See you next time.